Lesson 69, add and subtract radical expressions. Just a review of what radicals are. Radicals, or like radicals, are the same radicand. They have the same radicand and index, or the root. So in the example, if I had the square root of 5 and the square root of 5, they are like radicals. The root is square, and the index, or the radicand, is 5. Or if I had the cubed root, that's the index or the root, the cubed root of 8 and the cubed root of 7, they are not like, because the radicand is different. So like radicands, you have the same radicand. Like radicals, you have the same radicand and index. Unlike radicals, they are different radicands or index. So just like when we have variables and you're adding like terms, you do the same thing with radicals. So here we have 2 times the square root of 7 plus 4 times the square root of 7. We add the numbers in front. So 2 plus 4 is 6. The radicands are the same, so that stays the same. So 6 times the square root of 7. Next one, we have 4 times xy, square root of xy minus 6 times the square root of xy. Take the integers in front, so 4 minus 6 is a -2. They both have the same radicands, so the radicands stay the same, so square root of xy. Next one, we have 6 times the square root of 2 plus 8 times the square root of 11. First thing you should always look at is the radicands to see if they are alike, because if they are not alike, then you cannot add them together. So since they are not alike, we cannot add them together, so this would be our answer. Next one, 2 times the square root of 5 cubed divided by 7 plus 3 times the square root of 5 cubed divided by 7 minus 4 times the square root of 3r divided by 7. Now, since we have this in a fraction form, we have to make sure that the denominators are the same. The denominators are the same, so we can add and subtract them, but we can only add the first two because they have the same radicands. So we have 2 plus 3 is 5 times the square root of 5 cubed. And this is all over 7. And then we can subtract 4 square root of 3r divided by 7. That would be our answer, or you could also written it like 5 times the square root of 5 cubed minus 4 times the square root of 3r all over 7. Either way is acceptable, but we can't subtract the 5 and the 4 because the radicands are not the same. And that's the second one on this slide. The radicands are the same, so I can add them. 9 plus 8 is 17 times the square root of 5. A few more. Here we got 11 times the square root of a minus 23 times the square root of ab. The radicands are different, so I cannot subtract them, so these are my answer. 5 times the square root of 7 plus 3 times the square root of 2. I cannot combine them because the radicands are different, so this would be our answer. And the next one, the denominators are the same, they all have 5, and the radicands all have the square root of 2x, so I can combine them. Just remember in this last one, there is a 1 right here. So we have 3 plus 2 is 5, minus 1 is 4, and the square root of 2x divided by 5. Now, one thing we do need to check is to make sure that the numbers on the outside of the radical, we cannot simplify it. Like 4 and 5, I can't simplify that any further, so treat that as 4/5. That is in lowest terms, so this would be my answer. 4 times the square root of 2x divided by 5. Next one we need to simplify before we combine. So breaking down the radicals. And we've done that before, breaking it down with prime numbers or with perfect squares. So for this first one, I can break down the square root of 8m cubed. That would be like saying the same thing as the square root of 4 times the square root of 2 times the square root of m times the square root of m times the square root of m. And I can simplify that here. The square root of 4 is 2. Then I have the square root of 2. The square root of m times the square root of m is m. And then I have the square root of m left over. So when I simplify that answer, I get 2m times the square root of 2m. And then I bring down everything else, plus 2 times the square root of 2m, plus 4 times the square root of 2m. Now I check all the radicans are the same, so I can combine them. But this one has a 2m, and these don't have an m on the outside, so I cannot combine those. So this would be 2m right here. And actually, I forgot right here. Since I have that 2m right here, I also have this 3 right here. So I need to multiply that by 3. So now it's really 6m square root of 2m plus 2 times the square root of 2m plus 4 times the square root of 2m. So if I combine everything that I have on the outside, and I'm going to put that in parentheses here, so I have a 6m, and then I can add 2 plus 4, which gives me 6. And then all of those have the radicand 2m. So my answer would be 6m plus 6 times the square root of 2m. If you wanted to, you could just have 6m times the square root of 2m plus 6 times the square root of 2m. But the more simplified answer would be right here. Next one, we got c times the square root of 75c minus 20 square root of 27c to the third. We can break this down. This is the square root of 25 times the square root of 3 times the square root of c. Square root of 25 is 5 times the c out here times the square root of 3c. This one would be the square root of 9 times the square root of 3 times the square root of c times the square root of c times the square root of c. Put my minus sign here. Square root of 9 is 3. Square root of c times the square root of c is c. And then I have the square root of 3c left over. This, remember, was a 1, so 1 times 3c is just 3c. So now if I combine, they both have the same radicans. They both have the same number on the outside. So I have a 2c times the square root of 3c. This would be our answer. Next one, break down these. 20n cubed. So here, I know I have a 4 on the outside times the square root of 4 times the square root of 5 times the square root of, I'm going to do n squared times the square root of n. And now I can combine. The square root of 4 is 2, so 2 times 4 is 8. Square root of n squared is n times the square root of 5n plus 5 times the square root of 5n plus 3 times the square root of 5n. This would equal, parentheses, I can have 8n plus 5 plus 3 is 8. This is all with the square root of 5n. So this one was very similar to one of the first ones we did. So here, just combining like terms. Just be careful of what are like terms and which ones not. So this first part is not the same terms as 5 and 3. Next one, we got 3c squared. So this would be the square root of 3 times the square root of c times the square root of c. This one would be square root of 2 times the square root of c times the square root of c. So I have a 4 on the outside for this first one. Square root of c times square root of c is c times the square root of 3 minus 8. Square root of c times square root of c is c times the square root of 2. The radicals are not the same, so I cannot combine them. So this would be my answer. On the last one on the slide here, square root of 10a, I cannot break those down, so that stays as negative 11 times the square root of 10a. This one, square root of 25 times the square root of 10 times the square root of a. And this last one, square root of 16 times the square root of 10 times the square root of a. Combining like terms, here I have negative 11 square root of 10a plus 3 times the square 3 times 5, because the square root of 25 is 5, times the square root of 10a plus square root of 16 is 4 times the square root of 10a. Since the radicals are the same, I can combine them. So this is going to be 15 here. So negative 11 plus 15 is 4. 4 plus 4 is 8 times the square root of 10a. Answer 8 times the square root of 10a. So just pay close attention when you're solving them that you're only adding like terms or like radicals. And let's get through some application. First one, find the perimeter of a right triangle if the lengths of the two legs are 4 times the square root of 9 inches and 2 times the square root of 64 inches. And the hypotenuse is 2 times the square root of 100 inches. Perimeter of a triangle, you add leg 1 plus leg 2 plus leg 3 will give us the perimeter. Now for all of these, we can simplify the legs because the square root of 64 is 8. 8 times 2 is 16. So this is really 16. Square root of 9 is 3. 3 times 4 is 12. Square root of 100 is 10. 10 times 2 is 20. Now leg 1 is 16. Leg 2 is 12. Leg 3 is 20. Add them together. 16 plus 12 is 28. Plus 20 is 48. And these are all inches. So my answer would be 48 inches. Next one, a rectangular pool has a length of square root of 800 feet and a width of square root of 648 feet. Find the perimeter. For a rectangle, the perimeter of a rectangle is 2 times the length plus 2 times the width. If I substitute my numbers in here, 2 times the length, which is the square root of 800, plus 2 times the square root of 648. So I need to break down square root of 800. So this would be the square root of 100 times the square root of 4 times the square root of 2. So there's my 800. Square root of 648. Break down 648. So 648, let's say we divide by 4. Square root of 4. That gives us square root of 162. I can break down the square root of 162 by dividing this by 81. So this is square root of 81 times the square root of 2. And all I'm doing is just breaking down with perfect squares. So now from here, square root of 10, the square root of 100 is 10. Square root of 4 is 2 times the square root of 2. And remember, I have this 2 here. So that means I got 2 times 10 is 20. 20 times 2 is 40 times the square root of 2. Plus, here I got 2 times the square root of 81 is 9 times the square root of 2. And then I have this 2 here. So 2 times 2 is 4. 4 times 9 is 36. Times the square root of 2. Radicals are the same, so I can add them. 40 plus 36 would go as 76 times the square root of 2. And the perimeter would be in units feet. And the last one here. A rectangular garden is square root of 27a squared feet wide and the square root of 75a squared feet long. Find the perimeter. Again, the perimeter equals 2 times the length plus 2 times the width. Substitute for the length. I have square root of 75a squared plus 2 times square root of 27a squared. Let's break these down. Square root of 75 is the square root of 25 times the square root of 3 times the square root of a times the square root of a. 27 is the square root of 9 times the square root of 3 times the square root of a times the square root of a. Now we have this 2 on the outside, so 2 times square root of 25 is 5. Square root of a times square root of a is a times the square root of 3. So that gives us 10a square root of 3 plus, got this 2 here, so 2 times square root of 9 is 3. Square root of a times square root of a is a times the square root of 3. So 2 times 3 is 6 times a is 6a times the square root of 3. Add them together and we get 10a plus 6a is 16a times the square root of 3. This would all be in feet. So that is our lesson today on adding and subtracting radical expressions.